Hello everyone, this is Manohar Reddy, Department of Cybersecurity, Institute of Aeronautical Engineering. Today in this session I am going to explain you about IP Encapsulating Security Payload. So IP Encapsulating Security Payload. It is formally known as ESP. It is formally known as ESP. So IP security is the combination of both ESP plus IKE. So encapsulating security payload plus authentication header plus IKE, internet key exchange. So here the encapsulating security payload, which handles the privacy as well as authentication, which is used for to handling both privacy as well as authentication purpose. So IP security is the upper layer of the network security, network layer, and which is the security service added in the network layer. So in this IP security, we can have this encapsulating security payload as well as authentication header as well as internet key exchange. So which is used for authentication purpose as well as confidentiality purpose. So here the encapsulating security payload, it attempts for the authentication purpose. It attempts for the authentication purpose. And here IP security uses an encapsulating security payload which is more complex than an authentication header, which is more complex than authentication header. So AH is the authentication header which is embedded in IP security services. So a value 50 in the protocol field. So this entire protocol field 50 of the datagram informs a receiver that the datagram carries ESP. So value 50 in the protocol field of the datagram informs the receiver that the datagram carries encapsulating security payload. So that indirectly says that the data transferred in the form of datagrams, and here the value, the protocol field carries the value 50. So here we can look at this the diagram of IP header, which is a datagram of IP header. So here the IPv4 header field and TCP header field and the data contents. So each and every protocol contains header as well as data. So this is the header and this is the data. So and here the same datagram using IP security encapsulating security payload. So this is the datagram without having encapsulating security payload. But this datagram, is a packet or is a format, is a frame, anything you can say. This is the datagram which is insisted with the encapsulating security payload. So what it contains actually, so this is the IPv4 header along with this encapsulating security payload header, along with this TCP header and a TCP data, along with this ESP trailer as well as ESP authentication data. So here related to the ESP contents, ESP header is there, ESP trailer is there, and ESP authentication is there. So this all the fields indirectly attempts to the providing security services to this datagram. So from this TCP header to ESP trailer, it is an encrypted format. And from ESP header to ESP trailer, it is an authenticated format. And this is the encrypted format and this is the authenticated format. So now we can say that encapsulating security payload, which is more complex than the authentication header. So here from this diagram we can understand that the TCP header, TCP data and ESP trailer are the fields that are encrypted for it, and other than that ESP header field is also required for authenticated it. Is also required for authenticated purpose. As the figure shows that, so ESP adds that encapsulating security payload adds three additional areas to the diagram. So what are those? One is ESP header, and second one is ESP trailer, and the third one is ESP authentication. So ESP header immediately follows the IP header and it precedes the encrypted payload. So it is immediately follows the IP header as well as it precedes the encrypted payload. And the ESP trailer is encrypted along with the payload, and a variable size ESP authentication field follows the encrypted section. So these three fields are having in the ESP. So ESP uses many of the same items found in the authentication header. So whatever the contents are available in the authentication header, almost will have same items found in the ESP header also, but rearranges their order. For example, the ESP header contains 8 octets. So ESP header contains 8 octets that identify the security parameters index and a sequence number. So one is security parameters index and sequence number, so which consists of only 8 octets. So here 0 to 16 and 16 to 31. So security parameters index as well as sequence number. The ESP trailer consists of optional padding. So ESP trailer consists of optional padding and the padding length field, that is nothing but pad length, and the next header field that is followed by a variable amount of authentication data. It is followed by various variable amount of authentication data. So here this is the ESP trailer format, so which contains 0 to 31, and here which having octets of padding and pad length as well as next header and ESP authentication data. So these are all the fields are added extra in the ESP, which is comparing with the authentication header. So here the security parameters index and the sequence number are having in the ESP header, but in the ESP trailer it is having padding as well as pad length as well as next header and authentication data. It is a variable. So here from this padding is an optional. It may be present for three reasons. The first one is some decryption algorithms requires zeros following an encrypted message. So some decryption algorithms are having zeros followed by an encryption message. So zeros are following an encrypted message. And second one, noted that the next header field indicates the next header, that is like TCP header or IP header. It indicates the next header. It is shown in the right justified within octet field. The alignment is important because IP secure requires the authentication data that follows the trailer to be aligned to the start of the 4-octet boundary. Thus, padding may be need to ensure alignment also. So here 0 to 255 octets are having the size of the length or padding of the length. And third, some sites may choose to add a random amount of padding to each datagram. So eavesdroppers at intermediate points along with the path, they cannot use the size of the datagram to guess its purpose. So these are the fields that are having in the ESP trailer. So ESP, in the ESP, one is ESP header field is there, and second one ESP trailer field is there, and third one ESP data authentication data is there. So in the ESP header format, security parameters or index is there and sequence number is there. But in the trailer, it is having the padding of the field, pad length of the field, next header of the field, and ESP authentication data. ESP authentication data. So these are the fields in the ESP trailer. And look at here ESP header format. Look at here ESP header format. This is for without authentication header. Without authentication header. And here ESP encapsulating security payload with authentication. With authentication. So here it shows that without authentication, and here it shows that with authentication. So what it contains actually ESP header as well as ESP trailer. So the ESP header which is having without authentication here. So without authentication, what the parameters are having here? The security parameter index, and second one is sequence number. That is the ESP header. And this is all the encrypted payload, that is variable amount of data. And the next one, the padding variable, pad length, and indicates next header. So here it does not have any authentication data, ESP authentication data. So here it shows that next header indicates encrypted payload, but there is no authentication data. But here in this diagram, if you can observe, which contains the field authentication data, which is having 32 bits, So here the ESP with authentication. So ESP header field, which contains both security parameters index as well as sequence number, and here's ESP trailer, which contains padding, there is a variable, and a pad length as well as next header. So the next header indicates encrypted payload, which indicates authentication data, So this header format which does not contain authentication field, and here ESP with authentication, which contains authentication data. So which is not having authentication data and which is having authentication data. So that is the difference without authentication and with authentication of encrypted security payload, encapsulating security payload. And the header field says, the first one is what? SPI. SPI stands for Security Parameters Index. SPI stands for Security Parameters Index. So how many of the security parameters are involved? So each and every security parameter is termed as the number 1, number 2, number 3. And each and every will be having that index. And a sequence number. Those are the two header fields. And the next one, data part. So optionally, it may have an IV added in clear if it is necessary. So it is added, IV added. It has variable length padding. It has variable length padding. Sometimes it is needed for encryption as well as sometimes it masks encryption. So sometimes it is required for choosing encryption, and sometimes it is covered that encryption as a mask purpose. And sometimes used to mask traffic flow. The trailer part. So what the trailer part contains? The padding length. So trailer part contains padding length, next header, and in tunnel mode it would be set to 4. In tunnel mode, the trailer part it would be set to 4, and in transport mode it would be set to original packet data. So tunnel mode and transport mode. So what is the difference between transport mode and tunnel mode? So the tunnel mode indicates and transport mode indicates the services provided in between both either system to system or system to network. But in the tunnel mode, the services provide system to network as well as network to network. But here system to system as well as system to network. But in tunnel mode, system to network as well as network to network. So both. So system is having one type and the network is having one type. So both the communication, the services between system to network, it is a gateway process, gateway connecting process in between both system and the network. So in transport mode, it would be set to original packet data. And ESP can also have some network address translation problems. Network address translation problems as well as physical address translation problems. So NAT stands for network address translations as well as PAT stands for physical address translation. So how you are going to get the physical address or MAC address? Physical address or MAC address. So medium access control address. So you can find the system MAC address by using getMAC command. GetMAC command. And if transport layer information is used, so these are the fields which contains ESP header, ESP trailer, along with that ESP authentication data. So these are the fields in the ESP trailer format. And here the IP security in ESP transport mode. So we are already said that the transport mode or tunnel mode provided the services in between both system to system or system to network or network to network. So here how the IP secure in ESP in transport mode contains. So here this is the original IP before header, which is having the fields like version of the field, header length, type of service, packet length, ID, flags and a flag offset and time to leave and header checksum, source IP address as well as destination IP address. So these are all the fields contains in the IP before datagram. So in this protocol field, the type of protocol field indicates the next protocol of the data. So here, which indicates that protocol equals to TCP, which identifies that TCP header and TCP payload. That is nothing but protocol 6 and the TCP payload. So TCP header plus payload, which indicates from protocol equals to TCP. So this is the IP before. So in the packet format, so IP before header and ESP header and TCP header. So here IP before indicates TCP header without having ESP or without having encrypted data, without having authenticated data. But while comparing to this with having encrypted and with having authenticated, the new IP before datagram is follows like this. So what it contains actually. So see here, this is the protocol of IP before protocol. After IP before protocol, it identifies that it forwards that the next header is what? ESP. Next header ESP. It identifies that next header ESP. Again that the next header ESP indicates that ESP header as well as ESP trailer. So ESP header as well as ESP trailer. So here the protocol equals to ESP. From where? So the format is what? IP before header, ESP header as well as TCP header. Right, but here the IP before datagram with having ESP header indicates that the protocol of this IP before indicates that next ESP protocol. So now the protocol equals to ESP, which identifies that both ESP header as well as ESP header as ESP trailer as well as ESP header as well as ESP trailer. So if it identifies towards ESP header, and what are the fields ESP header contains actually? So two fields, which is one is security parameters index and second one is security sequence number. One is SPI security parameters index and the second one is sequence number. So those two are the fields from ESP header. And the next one ESP, the next indicates that ESP header indicates that TCP header. So next equal to TCP. So now next header TCP indicates that TCP header plus payload. But before that, ESP header contains ESP trailer also. So ESP trailer is what? It's having padding. It is having padding and pad length and next header. That next header indicates that what? A TCP header. So now TCP header and plus TCP payload available here. TCP header plus TCP payload available here. And next, authentication data. It is an optional. So which data contains ESP header plus ESP trailer is in the form of authenticated data. Is in the form of authenticated data. So the data which is having the fields contain in ESP, the data which is having the fields contain ESP is encrypted or authenticated data. Is encrypted or authenticated data. So this is the this color indicates that all encrypted purpose, and these dotted lines are indicates that authenticated data. Authenticated data. So this is the way we can understand that ESP, encapsulating security payload, provides security service in the transport mode. So one is without having ESP, and here this is with having ESP. So here only the two things are happening. The IPv4 header protocol, the next header protocol indicates that next header which is having ESP, and that ESP header indicates that ESP header as well as ESP trailer. So ESP header is there, which contains security parameter index as well as sequence number, and ESP trailer indicates that padding, pad length, and next equal to TCP. So ESP trailer of the next header indicates that TCP header plus TCP payload. So now this is the way we can understand that IP secure in transport mode with the help of ESP, encapsulating security payload. And next, IP secure in ESP tunnel mode. ESP in tunnel mode. So tunnel mode indicates that providing services between network to system or network to network. So provides the data services or transfer services in between both network to system as well as network to network. So the same thing. So what is the exact original IPv4 diagram data? So which is having both IP header as well as TCP header, because every IP header format indicates that next header as TCP header, but when ESP is placed in between that, it indicates that ESP and then next TCP. So here the original IPv4 datagram is the fields contains both version of the IPv4 and the header length and the type of service and packet length and ID and flag offset, time to leave, header checksum, source IP address, destination IP address. So these are all the fields which contains in the IP header. And here the field which is represented protocol next header, the protocol equals TCP. So the TCP header indicates that TCP header protocol equals to 6. So here the TCP header plus TCP payload, it denotes that both the TCP header plus TCP payload. So this is the IP secure in ESP tunnel mode without ESP. This is the IP security in tunnel mode without ESP. So this is the IPv4 diagram with ESP. So what are the fields it contains? So same the way the protocol fields contains like version of the field, header length of the field, type of service, packet length, ID of the field, flag offset, time to leave. Protocol indicates that the IP header contains the next protocol is what? ESP, and which indicates the next header TCP. So the same way it is happening in the tunnel mode also. One is transport mode and the second one is tunnel mode. So here the protocol indicates that ESP and header checksum field. So protocol indicates ESP which pointed towards ESP header as well as ESP trailer. So it pointed towards both ESP header as well as ESP trailer. So ESP header fields contains what? Security parameters index as well as sequence number. Both are in ESP header. And similarly, the ESP header field next header indicates that TCP header. So which is having trailer port padding and pad length and next header. Padding, pad length and next header. So here the TCP field indicates that the next header of the IP header as well as TCP header plus payload. IP header as well as TCP header plus payload. So why it comes against IP header in the field means it provides the service between IP secure. It provides the service between IP secure. So here by understanding that IP secure, we can have this IP header in one more time. We can have IP header in one more time. So this is the way the protocol ESP indicates that ESP header, and ESP header indicates that next TCP header, and TCP header next indicates that IP header both as well as TCP header plus payload. So which is having both the TCP header plus payload options, and along with that authentication data also. So this is the way IP security in ESP tunnel mode indicates. IP security in ESP tunnel mode indicates. The next, the previous we discussed in this header fields both ESP header format with authentication, without authentication. So once we revised all the topics. So IP security, encapsulating security payload. So encapsulating security payload is a service of IP secure which indicates that IP header as well as trailer, ESP header as well as ESP trailer. So here it provides an authentication as well as privacy. It provides both authentication as well as privacy mechanisms. So this is the original header of IPv4, and which contain IPv4 as a header and TCP as a header and TCP data. Again, this IPv4 header with ESP format. So here IPv4 header is there, and ESP header is there, and TCP header is there. Along with that TCP data, ESP trailer, and ESP authentication. So IPv4 header, ESP header, TCP data, along with that ESP trailer, ESP authentication. So from these, the fields are having ESP header, ESP trailer. So what are the fields in the ESP header? So it contains both the security parameters index as well as sequence number. One is security parameter index as well as sequence number in the ESP header. And the ESP trailer contains 0 to 255 octets of padding. The fields contains padding field and pad length field and next header field and ESP authentication data field. So these are all the fields which are presented for the reasons of description algorithms followed with the encryption message and justified with the octet field and choose to random amounts of padding to each datagram. So each and every datagram, IPv4 datagram having with authentication and without authentication. So without authentication as well as with authentication. So here ESP without authentication. So ESP encapsulating security payload without authentication. So which contains both security parameters index and as well as sequence number, but which does not having ESP authentication data. But here ESP having both ESP header as well as ESP trailer as well as ESP authentication data. And here the fields are there, header fields and data part and the trailer part and also what it facing the problems. And here the IP security in ESP transport mode as well as ESP without transport mode, without ESP transport mode. So here the ESP is not there. This is the IP before diagram without ESP, and this is the IP before datagram with ESP. This is without ESP and this is with ESP. So in the without ESP protocol is not there, but in the ESP, the protocol represented that next header is ESP, and the ESP protocol pointed to the next header ESP header as well as ESP trailer. So ESP header contains both security parameters index sequence number, and here ESP trailer contains both padding and padding length and TCP. So this is the transport mode, and here in the transport mode IP secure protocol is not repeated again. But in the IP security in tunnel mode, ESP in tunnel mode, the IP header forms are come again one more time. So this is the ESP tunnel mode without ESP tunnel mode, and this is the with ESP tunnel mode. So this is the without ESP and this is the with ESP. So with ESP in tunnel mode, the IP header comes again for the security purpose, and which is having both ESP header, ESP trailer as well as authentication data, along with that TCP payload and TCP header. So this is the way we can understand that ESP, how encapsulating security payload works in both transport mode as well as tunnel mode. So by doing these services from transport mode and tunnel mode, we can say that the ESP provides a security and it is a part of IP security policies, IP security services, IP security services. So this is the way we can understand, and thank you.
Like, share and subscribe. Hit the bell icon for more updates.